All right, for the next question, let's take a look at the cities that have the most transaction totals. And for here, again, quickly, I'm going to go back to my schema. I'm going to look for, again, you can scroll down or you can search for in your browser, city. I'm going to add in my select, give me the geo network city. And give me the totals. Let's do totals transactions. And let's also return a distinct count of the visitors from that city. So we've got each of the cities, we've got transactions associated with those. And the only thing we're missing now is the table that we're actually pulling from. And of course, making sure that we have our legacy SQL disabled. One of the first things that you're going to get is a very common error. If you're referencing things that have aggregations in them, if you're counting the visitors, then of course we need to do group by. And let's see if that gets us closer. If we did an aggregation on the full count of visitors and we wanted to say, all right, well, let's do the sum of the totals transactions. Then you execute that. And we will get a result. So we have a bunch of different interesting cities that could have had only one transaction or one visitor that visited from there. Now, if you wanted to order the results, the calls that you would use is order by. And so you wanted to order by the total number of distinct visitors. So who visited the most? Which city has the most visits from? Let's see. In this particular data set, it's not available in this demo data set, so we'll ignore that one. And then we have Mountain View, New York, and then San Francisco. One thing that I will caution is, for those of you who've been around and used SQL quite a lot, this sum total transactions, as you'll see when we just preview the data set here. Let's take a look at this particular visitor ID. You can see rows 1 and 2 are the same. And you can see that the total transactions is 1. We have to be very careful that the total transactions we're not double counting. So the total transactions for that particular visitor, we need to see and take a look at. The transactions probably means one particular order, which could have multiple different products. So it looks like what we've done in our particular query is not the total number of unique transactions, but the number of products that were ordered. So we're actually going to rename this total products ordered. And we'll add in a filter or a sort. We're going to find the city that ordered the most products. Let's see if it's also San Francisco or Mountain View. And as you see when we execute this query, that New York wins in terms of the number of products ordered, but it looks like it has fewer visitors. Mountain View had the most visitors besides the one that was not included in this data set, but it had fewer products ordered. So if you wanted to get that ratio, we could just do a simple calculated field. So we could say, take all of the different products ordered divide that by the total number of visitors, and we get a nice ratio here. As products ordered, average number of products ordered by city. And this will be really interesting because you could have some cities that have very few visitors, but are ordering a ton, and you may want to target those a little bit more for promotions. So let's see. So we now have that returned. Oh, this is going to be cool. So we have the average number of products ordered instead of sorting by that. Now let's sort by the average number of products ordered. And we'll find, I'm hoping some cool cities that have had, yeah, all right, awesome. We have Jakarta, who had 7 visitors, but they ordered 254 products. So you get some really interesting statistics here. So maybe this will influence your promotions or however you want to further incentivize or reach out to these folks and basically say, you ordered a ton of products. We want to see what you're doing with them, or if there's any way that we can be of additional support. Now, one thing we'll close on here is if you want to do things like filter after you've already aggregated. If you're filtering after an aggregation, you're not going to be doing, let's just do it the wrong way. If you're doing where the average number of products ordered is, say, greater than 20. And if you were to execute this, let's see what that would return. It's a common error. So there's 2 errors in here. Unrecognized name, average products ordered. And then you could stare at this for as long as you want and basically say, this is the exact same field name as I've specified here. But there's 2 actual errors. One's in a SQL syntax error and the other one's a logical error. So the SQL syntax error is, instead of actually doing this inside of the where clause, if you're filtering on aggregations, that's actually not done in the where clause. It's done after the group by, and it's saying group by the city, but filter after you've grouped is done by using a having clause, having average products ordered greater than 20. So let's execute selected again on this. And you can see the result that is returned. The other error that's a little bit more insidious is that, hey, why on earth does it recognize this field now, average products ordered, inside of the having clause, but not inside of the where clause? And that's one of the fundamental insights of filtering. That field, when BigQuery goes out and executes this, and this is true for SQL in general, is it'll go to the data set first, all the different rows, and it'll immediately look to invoke that filter first. So right now, it goes to the data set, it looks for a field name average products ordered. And because it's a calculated field that's done row by row, it's not available initially for that first data set filtering. So that's why you can't use aliased fields or calculated fields inside of a where clause. Now, what you could do inside of your where clause is you can copy and paste. It wouldn't be this because this is an aggregated field, but say you had something like GeoNetwork City and you concatenated something onto the front or on the end of it. You could copy and paste that calculation that you're doing inside of the where clause and then pretty much have that duplicative code and filter it out that way. So the where clause can actually take a calculation, but that gets in a little bit of code duplication. But what you more likely want to do, as we'll cover in future courses, is use something like a subquery or use a common table expression or a with clause to break apart one big query into 2 separate queries. And we'll show you how to do that in our advanced course. But for now, we've got the great insight that we've got a particular city that has a lot of products ordered, and it's a high number of products ordered per each of the